For our project, we chose string theory. String theory is a theory that describes all matter as being made up of one-dimensional strings of energy vibrating through 11 dimensions. A string is about 10 to the negative 33 centimeters long, which is extremely close to Planck's constant, 6.626 times 10 to the negative 34th. Strings vibrate at different frequencies, and the varying frequencies correspond to different particles in the Standard Model, which makes the world around us. The particles that are part of the Standard Model make up subatomic particles, such as protons and neutrons, which then make atoms and in turn everything in the world. The purpose of string theory is to combine quantum mechanics and general relativity. Quantum mechanics is the study of things so small that the laws of classical physics break down at that level. It has led to a reevaluation of physics in order to make sense of the strength properties at this level. General relativity is a theory proposed by Einstein that describes gravity as a warping of space-time. Both of these theories are accepted, but they are conflicting, so string theory unifies them.
A dimension is defined as the minimum number of coordinates.
A key part of string theory is the idea and conceptualizations of dimensions of space and time. A dimension is defined as the minimum number of coordinates needed to describe the location of something in space and time. Things in a lower dimension cannot perceive things of a higher dimension despite existing in a higher dimension, but things in a higher dimension can perceive things in a lower dimension. So if I drew a character on a piece of paper, he'd be two-dimensional, thus only capable of perceiving 2 and 3D things despite existing in 3D. This stick figure is two-dimensional but exists in the third dimension. Dimensions also build upon each other, so a higher dimension would be built of lower dimensions. An example of this is how a line is one-dimensional, but a square is two-dimensional, and a square is just 4 one-dimensional lines put together. Dimensions are very important in string theory because the math of string theory predicts the existence of 11 dimensions. So since we are three-dimensional beings, we may exist in 11 dimensions, but only be able to perceive dimensions 3 and below. The dimensions speculated in string theory are combined in Calabi-Yau manifolds. The strings vibrate through different manifolds, and thus the strings vibrate through 11 dimensions. This vibration gives the string the corresponding particles their unique properties. The particles the strings make up are called elementary particles, and these are shown in the Standard Model. These particles are zero-dimensional, which means they interact over zero distance, which does not allow gravity to affect these particles in their interactions. Strings fix this problem because they are one-dimensional, so they smear interactions over small distances.